Okay, before we get kind of going with this lesson, let's just talk about what we're going to end up trying to do. We're going to try to connect our transformations of functions that you've studied in the past to our trig families. And then we're going to be able to identify transformations of trig graphs, and then eventually, not today, we'll use those transformations to actually sketch a graph of the function. So on your reference sheet from section 5.0, I want you to go back and fill in these first two tables. So pause the video for a second and fill in these first two tables, because you should be able to take those right off of your reference sheet. So fill those in and then come back when you're done. Okay, so you should have something that looks like this. Just as a quick recap, all of the functions have a period of 2 pi except for your tangent and cotangent function. All of your midlines are at y equals 0 before you do any transformations. And your amplitude is essentially 1 except for tangent and cotangent, which truly doesn't have an amplitude. When we talked about cosecant and secant, we said, you know, technically there's not an amplitude, but when it comes to graphing, it might be easy to say that there's an amplitude of 1. So I want to just take a minute and look at the actual equation as it's written. So if we just take a look at our sine function, this equation here, okay? We've got y equals a times sine of bx minus h plus k. 3 out of those 4 variables you should be familiar with. A, h, and k you've encountered in all of your other functions. And you'll notice that it's the same throughout all of the 6 trig functions. The only thing that changes is the actual trig function itself. So let's kind of focus on each letter and talk about what it does. So A, what you know it as is your vertical stretch. What we call it for our trig functions is it's going to determine the amplitude of that function. So vertical stretch and amplitude just mean the same thing. And how to identify it in how to identify the transformation is literally whatever A is equals your amplitude. Okay, it's pretty simple. Now I'm writing that here, but some of them won't be quite as simple. Okay, I'm going to skip B and come back to that in a minute. I'm going to go actually to K next. K, you know as your vertical shift. How much it goes up or down, depending on the function. That doesn't change. We just call it our midline. So y equals k. Actually, I'll write that on the next box here. This is going to determine where our midline is on the function. So how to identify that in the transformation? Our midline is going to be the equation y equals k. All right, next. To find or to talk about B. So B is a brand new transformation here. This is one that you don't maybe know, but in some of your classes, maybe your teacher briefly talked about what B does. It's actually your horizontal stretch. Now, what that means for the trig function is it's going to determine the length of the period. So how we find that is just a pretty simple proportion or ratio, actually. What you're going to do to find the length of the period, because it's not just B, you're actually going to have to take whatever the default period is. So for sine, whoops, wrong color there. Sine, cosine, cosecant, and secant, you're going to take the default period of 2 pi and divide by B. For cotangent and tangent, you'll take the default period and divide by B. So that would just be pi divided by B. And then finally for H, H you know as your horizontal shift. And that's one that I think most of you remember from last year. The difference is this year with that B involved, we have to kind of work a little bit harder to figure out what our horizontal shift is. Now, what we call that is a phase shift. It's the same thing as a horizontal shift, we just call it a phase shift for trig functions. Now, to find that, we have to set up an equation that has bx minus h set equal to 0, and then we solve for x. And what that gives us is the starting point for our graph. So I'm actually going to start towards the bottom of your page here and do the helpful hints first. So how should you find the period of the trig graph? I'm just going to reiterate what we said on the previous page. To find the period of the trig graph, you take your default period, whatever it is. So for sine, cosine, cosecant, and secant, we're going to take the default period of 2 pi and divide it by b. For cotangent and tangent, we take the default period of pi and divide by b. And either way, that's going to give you the period of your transformed graph. How should you find the phase shift? Again, just reiterating what we wrote on the previous page. You're going to take bx minus h, set equal to 0, and solve for x. And that will give you your phase shift, how much you're going to move left or right. All right, let's go ahead and practice with a few. Okay, for the first problem, we're going to focus on sine. Now, the actual graph this time, the function that we're graphing doesn't really matter because we're just finding the different pieces of the graph. We're not actually going to graph it. The only time it will matter is when we go to find the period of the function. So to start with, it's nice to kind of label A. Now there's a 1 here in front of my x, B, H, K to kind of help us identify our different values. So our midline is going to come from whatever K is. And we talked about how it's just y equals K. So y equals, -5. The amplitude is going to come directly from A. So our amplitude, I guess I don't have to write it since it's right there, is just 2. The period of the function is going to come from our b value, and we take our default period, which for sine is 2 pi, and we divide by b, which is 1. Well, that just ends up being 2 pi. We didn't change the period at all. And then finally, our phase shift. This determines how much we move left or right. So we're going to take that x plus pi over 2 and set it equal to 0. And then we solve for x. So I subtract pi over 2 from both sides. Now what this tells me is that since x is negative, I'm actually going to move left whatever that amount is. So I will move left pi over 2. That would be my phase shift. Okay, next up we have cosine. Once again, let me rewrite this so I can actually kind of put in where A, H, and K would be. So A would be 1. We have 1/3 x. I'm just going to put plus 0 here just so we can kind of label all of our different values. So we have A is 1. We have B is 1/3. We have H is 0. And we have K is 2. So we start with our midline. Our midline would be y equals whatever K is, so that's just 2. The amplitude is whatever A is, so that's just 1. The period is taking the default period, which for cosine is 2 pi, and dividing by b. Now we've done a lot of work with these complex fractions. This is the same thing as saying 2 pi times the reciprocal of 1/3, which is 3. So the new period for this function is 6 pi. And then finally our phase shift, there isn't one because it's 0. All right, next let's try a tangent graph. So the only time this tangent becomes important is when we start thinking about the period of our function. You do not have to do, well, I'm just going to add in plus 0 here. So again, A is 4, B is 2, H is pi over 2, and K is 0. So when we start this, we start with our midline. Our midline is just y equals 0. Amplitude, you know, with tangent, there really isn't an amplitude. So there's no amplitude. However, in parentheses here, I'm going to write there is a vertical stretch for this function because that's what our amplitude is really telling us anyway, of 4. And then the period of our function, now we take our default period, which for tangent is pi, and we divide by b. That's our period, pi over 2. And then finally, our phase shift, we take that 2x plus pi over 2, set it equal to 0, and we're going to solve for x. So the first thing I'll do is subtract pi over 2 from both sides. And then I'll divide both sides by 2, which is the same as multiplying by 1/4. And we get pi over 4. So because it's positive, we're going to move right pi over 4 units. All right. Let's go ahead and talk about this one because it's got some interesting things happening. I'm actually going to rewrite this, and you could leave it like this, but let me rewrite this. 1/2 cosecant. I'm going to distribute that 1/3. So I'm going to get 1/3 x minus pi over 9. Now you'll see something in a minute, and maybe you'll be able to do this without rewriting it. So that's what y is. Okay, so I'm going to label these just like I have been. A, B, H, and K. So starting with my midline, that's y equals 3. So amplitude, this is one where you could either answer none or you could answer with A. I would take either one. I'll say none again, but our vertical stretch is going to happen, and it's going to be 1/2. The period, we take the default period, so we're looking at cosecant, which has a default period of 2 pi, and we divide by our b value, which is 1/3. And we just did one like this. 2 pi times 3. So the period of this function is going to be 6 pi. And then finally our phase shift. So I'm going to set 1/3 x minus pi over 9 equal to 0, and I'm going to solve for x. So I'll get 1/3 x if I add pi over 9 to both sides. And then either divide by 1/3 or multiply by 3. Either way, you're going to get x equals pi over 3. Now, the shift will be to the right because that's positive. So right pi over 3 units. Okay, I want you to try the last two on your own. So go ahead and pause the video, see if you can find the requested information for the last two functions, and then replay the video and come back and check your answers. Okay, take a moment, check your answers. If you have any questions, let me know tomorrow when we meet or the next time we meet. And then you may want to update your reference sheet from 5.0 with some of the information from today. And we can talk about that in class if you have any questions about what you should be putting on it. All right, have a great day.